Everyone, good afternoon. To authors and invited guests, welcome to Technical Session 9C. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event took place on April 4th, 2025 in Bangkok, Thailand, while the virtual event is being held via Zoom over 2 days, April 5th and 6th, 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chairs. We have with us Professor Osmane Diallo, who is an assistant professor in the Department of Informatics at the University of Essen, Senegal. His expertise lies in software engineering, distributed computing, and algorithms. He is dedicated to advancing research and education in these fields, contributing to innovative solutions in computing and information technology. Thank you for your valuable presence, sir.
Thank you very much, Mrs. Ishita Sorian, for introducing me. Thank you also for giving me the floor. Good morning, everyone. Good morning, everyone. Good afternoon for the dear colleague in Bangkok. I would like to say some word, if you allow to me.
Yeah, sir. Please go ahead.
Thank you very much. Okay. On behalf of my co-chair, Professor Pritesh Kumar Prajapati, it's really an honor and a privilege to be sharing this technical session on the 9th International Conference on Communication Technology for Intelligent System, ICTIS 2025. At the outset, I would like to thank the organizing committee, and particularly Dr. Amit Joshi. By the way, I had to congratulate you for organizing the important conference, which is indeed a wonderful opportunity for everyone to come together, discuss, explore, and share the experience for promoting, increasing the understanding role of information communication technology and the evolution of intelligent system. I welcome all of you in this session. And we are looking forward to hearing the various presentation for participants as well as learning from everyone. Thank you.
Thank you, sir. I'd also like to introduce our session chair, Dr. Pritesh Kumar Prajapati, who's currently working as an assistant professor at the KD Patel Department of Information Technology, CSPIT, Gujarat. He has almost 11 plus years of academic experience. His research interests include information security and data deduplication. He has published over 16 papers and voluntarily served as a technical reviewer in 35 plus Scopus and Web of Science journals, conference proceedings, and books. Thank you for your valuable presence, sir.
Thank you.
Thank you, sir. Now I'd like to start with the papers. We have our first paper presenter with us, Rishabh, who with the paper titled A Review of AI-Powered Symptom Analysis and Predictive Telemedicine Platforms, Transforming Healthcare Delivery with Machine Learning and Generative AI. So if you're ready, then you may start with the presentation. Sir Rishabh? It seems we do not have him yet. We'll be moving on with our next presenter, Pankaj Verma, sir, with the paper titled A Study on Software Defect Prediction Using TabNet and Ensemble Machine Learning Models. Sir, if you're ready, then you may go ahead. Sir Pankaj Verma. Moving on to our next presenter, Mananya, with the paper titled A Web Scraping-Based Approach for Efficient Data Collection in Educational Institute Mascot Design. Ma'am, if you're ready, then you may go ahead.
Hello.
Hello.
Let me share my presentation.
Sure, ma'am.
Okay, have you seen the presentation?
Yes, ma'am, it is visible.
Okay. Hello everyone. My name is Mananya Nimpisan. I am a representative from the Faculty of Informatics at Mahasarakham University, Thailand. And today I would like to share our research about mascot design. The title is a web scraping-based approach for efficient data collection in educational institution mascot design. In this presentation, I will explain how we use web scraping to collect data and how that data help in designing a mascot for our faculty. Okay, before I explain about research method, I would like to talk a little bit about mascot design. A mascot is not just a cute or decorative character. It is a symbol that represents the university's identity, values, and spirit. It also helps students feel more connected and engaged with the university community. To design a good mascot, we cannot simply gaze or rely only on imagination. We need real data to create a design brief and house to guide the creative process. That means understanding things like which colors are mostly used for text character and base reflect our faculty's identity, what symbols represent different departments, and what design styles are popular and appropriate, and what facial expressions create emotional connection. So usually this kind of data can be collected through interviews and surveys, which are still very important, especially when we want to understand specific groups and internal perspectives. But in this case, we would like to gather a large number of design data from a wide range of sources, including global trends. That's why we use a technique called web scraping. So web scraping allows us to collect a high volume of data in a short time. This helps us explore a broader range of mascot styles, symbols, colors, and emotions that are currently used in the real world. In the next part, I will explain how we use web scraping step by step. Okay, first we define the data sources. This includes university mascot galleries, design platforms like Behance, Pinterest, and even AI-generated image sites. Then we set up a tool called Scrappy, which is based in Python, to automatically extract data from those sources. And we collect color schemes, symbol, design style, and also analyze facial expressions and poses that appear frequently in modern mascots. Although I am not a technical lead in this part, I work closely with our teammate who specialize in web scraping. Actually, my area is graphic design. So my role focus more on design analysis and selecting the visual elements that would guide the creative process of mascot development. So in this stage, with collaboration between technical data collection and design interpretation. Okay, from our web scraping process, we collect four main types of design data to help guide mascot development. First, we look at the color schemes. We found that many technology-related mascots use blue tones, which matches our faculty identities. And also saw accent colors like silver, yellow, and white used for contrast. And second, we identify symbolic elements. For example, circuit lines represent computer science. Speech bubbles relate to communication because we also have communication art departments, and have map pins relate to GIS. We also have geoinformatics department too. This symbol help reflect different departments within the faculty. And third, we analyze character design trends. One widely recognized concept is called baby schema. Baby schema is a psychological idea that involves features like a big eyes and round head, small features like small nose, small mouth, which naturally make character appear cute and friendly. Another trend that we observed was the use of minimalist design with clean lines, simple shapes, and fewer details. The style helps make the mascot look modern, easy to remember, and suitable for digital platform. And finally, we study facial expression and poses. Many mascots have smiling or curious faces. Common poses include waving, holding a laptop, or standing proudly. These elements make the mascot feel more alive and approachable. After collecting the design data, we invite 5 experts to review our results. They look at all 4 categories: color schemes, symbols, styles, style trends, and emotion expression. All 5 experts agree that the data is valid, reliable, and suitable for creating a mascot and reflect the university identity. This step helped confirm that our web scrap data could be trusted and used confidently in the design process. After analyzing the visual data, we identified several key trends. Blue tones are commonly used in tech and educational mascot, aligning well with our faculty identities. And for the symbol, help represent different fields like speech bubble, communication, and map pins. And for character design trend, baby schema concept appears frequently with large eyes and round shapes, making mascot look more friendly. And overall, clean and modern design styles are preferred for clarified and digital use. This insight inform our mascot design direction. This finding help guide our design direction in the next step. And this is our mascot prototype, designed based on the insights we gather from web scraping and expert validation. We apply the most common color palette found in the data, blue as the main color. Blue as the main color with gray and white as supporting tones. This combination helps create a modern and professional identity. The character design applies the concept of baby schema, featuring large eyes, round forms, and gentle facial features. These traits contribute to a friendly and approachable appearance, making the mascot more visually appealing. For the symbolic elements, instead of placing every concept directly on character body, we choose to show them through the props and accessories. This keeps design clean and easy to understand, while still reflecting key fields from faculty, used as computer science, communication arts, creative media, and geoinformatics. These are represented through items like a chest badge based on the faculty logo, and the abbreviation MSU shown in the font that resembles circuit patterns to highlight the connection to the technology. The pose is confident and welcoming, smiling, winking, and holding devices, which reflects the energy of a digital age academic mascot. This prototype will be used in the next phase of our research to collect feedback from stakeholders and further improve the final mascot design. In conclusion, our study shows that web scraping can be an effective tool for collecting and analyzing visual data for mascot design. The expert validation confirmed the quality of the data, and the insights help us shape a prototype that reflects the faculty's identity. Our next step is to test this prototype with real users and stakeholders and we'll look forward to refining it further based on their feedback. Okay, thank you for your attention. This research is still in progress. We look forward to improving the mascot further with helpful feedback. If you have any suggestions, I would be happy to hear them. Thank you. Yeah, that's it.
So, yeah. This is Dr. Pritesh Kumar Prajapati. So, may I know which techniques you have used for the web scraping?
Excuse me?
Just a second. Yeah. Which techniques or methods you have used for the web scraping to collect the data from that internet?
Python technique. This part is my colleagues just did is because my area is design, and actually
Okay.
I don't do this part. I
Fine.
just analyze
Thank
the
you.
data. Yes.
By the way, good design. Very good.
Thank
Good
you.
slides also.
Thank you.
Mm. Thank you. It's Professor Usman Jallo. Thank you for your presentation and congratulations. It was interesting. Does your proposal include a technique to avoid any anti-scrapping measure deployed by website to protect their data?
Sorry, my listening is not that good. Could you please speak more slowly?
Does your proposal include a technique to avoid any anti-scraping measures deployed by website to protect their data?
To protect the data?
To protect the data, because sometimes it is an obstacle to when you want to have data from other website. There are systems that they make to block the web scraping.
Sorry, sir. In this part, I think I will go back to talk with my team again because I just collect the data from my colleague and just analyze and pick up
Okay,
elements
okay.
of design. So sorry, I
Okay,
cannot
thank you.
add.
Thank you, thank you.
Thank you.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Nurul Fatin with the paper titled Authentication Using Identity-Based Encryption in Edge Computing for Intelligent Transportation Systems. Ma'am, if you're ready, then you may go ahead.
Okay, thank you. Okay. Hi, good afternoon, everyone. I am Fatih Batine. I will be presenting a part of my research on authentication using identity-based encryption or IPE in edge computing for intelligent transportation systems. So we also call it as ITS, and for the rest of the presentation, I will be refer to intelligent transportation systems as ITS. Actually, ITS is where intelligence meets transportation systems. So basically, we can say ITS is actually an integration of ICT and transportation systems to enhance the efficiency and the sustainability of the transportation systems, especially in the urban areas where there are numerous of vehicles, users, and also facilities. Okay, there are so many technologies have been implemented in ITS like AI, machine learning, IoT, edge computing, and so many more. But these technologies is actually attached with security and privacy issues. Why I said so? Because let's look at this diagram. Okay, this is what I illustrate as ITS communication, where we have vehicle to vehicle communication, vehicle to infrastructure, and on top of that, we also have data processing in edge computing. And for your information, in this work, we focus on using edge computing because we want to exploit the advantages of processing data at the edge of network in order to reduce latency in processing real-time data. Why? Because we want to increase the efficiency of data sharing. That's why we will use edge computing. So we propose identity-based encryption in authentication in order to secure the data and private information of users. Why? Because authentication is actually a process of granting or denying access to entities in the system, okay? In order to be involved in the data sharing, like before they can request and sharing data in the system, they have to be authenticated as a user that will be granting and have access to the system. Okay. Usually in conventional encryption, a public key is generated randomly and managed by the PKI or public key infrastructure. But for identity-based encryption, it uses a vehicle's public information as the identifier. So it does not require to generate a public key using PKI. Okay, so in this work, we propose to use the vehicle's public information itself, like vehicle's registration number, the type of vehicle, and also vehicle color to as the identifiers, so that we can reduce the use of private information of the users. Like this is actually inspired and based on the ticket issued by authorities when there is traffic violation happen. So this information is actually public and everyone of the root users will know about this identifiers because they can see the vehicle's registration as the plate number at the back and in front of the car and the type of vehicle and also the color of the vehicle itself. So why we propose to use identity-based encryption? Because first and foremost, it does not require complex certificate to very minimal key management. Okay, and the second is requested user may retrieve the secret key more easy because they need to use only the public information of themselves, like we discussed before. And then most important thing here is because identity-based encryption can handle multiple requests at one time, which is very ideal in ICTIS environment because it processes a plethora of data. So we need to reduce the time processing in order to enhance the efficiency. So this is the model of authentication that we propose. Like previously, we talked about the communication in ICTIS, which include the application layer, data and service layer, network layer, and perception layer. So for authentication process, it will always happen in the application layer because it is the first thing that need to be done before it can access data in the systems. Okay, so here it's like a new vehicle will request and then the server will approve or disapprove the request based on the identifier that they presented. Okay, so this is the purpose process happened in identity-based encryption in authentication. It's similar to other encryption except that in setup stage, each server will determine the security parameters to generate the master public key and also public parameters. So when a new request comes from a user in this work, it is a vehicle, they will request and then the server will authenticate and trigger the server again to generate secret key. And then it will match with the key generation in the setup stage and then return the public key to the user. And then Next, once the user gets the public key, it will request the data and encrypted data will be returned to the user. And last but not least, using the in order to request, to decrypt the data, in the data access, it will request secret key which generated previously, and then from there it will identify if it is actually authenticated user or not. Then only it will secret key will be written to the user to decrypt the data. Okay. So in a nutshell, technology is actually double-edged sword, which comes with pros and cons. But making use of the technology also, we can mitigate the constant issues of ITS. In this work, we focus on latency, security, and privacy issues because encryption can conceal data that are being shared. But identity-based encryption actually offers more than that, which it will secure the data from unauthenticated user and protects the private information of users, because in this case, we only use public information instead of using any private data of the users. And we use edge computing because edge computing able to process data at the edge and will reduce the latency, which then enhance the efficiency in ITS. So that's all from me. Thank you so much.
Yeah, hello. So what about different attacks of IB? So how you have overcome with that particular attacks?
Sorry, sir?
Identity-based encryption, right? You have used this particular terminology in your research. So there are
Yes.
some security attacks also. So how you overcome with that particular attack, like
You mean the security threats that comes with the IBE itself, right?
correct. So how you
Okay.
overcome with that particular attack in your system?
Actually, I'm still working with my team to make sure that the mathematical modeling is really can protect the data, and we plan to do the security sorry, what we call that, we will test if it will be effective against cyber threats. So for now, we are in the phase of
Okay, so you have developed the prototype and you have done that particular use case of that ITS, right? Using IB.
Yes.
Okay, good. Thanks.
Thank you.
Hi.
Hi.
Congratulations for your presentation.
Thank you.
Did you deploy a prototype of your proposal somewhere for testing and validation?
Not yet.
Okay. Thank you.
Thank you, Prof. Thank you, everyone.
Thank you, ma'am. Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Prasanna G. Paga with the paper title Design and Realization of a Stub-Loaded Tri-Band Chebyshev Filter for NAV IC Satellite Applications. Sir, if you're ready, then you may go ahead.
Madam, I am just waiting for other team members to join.
Okay. So shall we proceed with another presentation and then?
Yes, madam, yes.
Okay. Our next presenter, Govind Khandelwal, with the paper titled Different Approach to Alzheimer's Disease Detection Using Convolutional Neural Networks. So if you're ready, then you please start.
Yes, ma'am. I'll share my screen once.
Sure, sir.
Wait. I think Prasanna ma'am is there.
Yeah, he's gonna present next.
Hello, sir. There is some issue. Some other faculty members have to join actually.
Okay, no problem.
Okay.
Sorry.
Sir Govind, you can go ahead.
I hope my screen is visible.
Yes, sir, it is visible.
Yes.
AI isn't about throwing the most complex model out there at a problem and praying it works. Good morning, everyone, or good afternoon. I am Govind Khandelwal, currently pursuing my BTech in CSE from Vellore Institute of Technology, Vellore, India. And today I'll be presenting a paper titled Different Approach to Alzheimer's Disease Detection Using Convolutional Neural Networks. This presentation will cover the design, the data, the results, and the future implications of our research with respect to AI and AI in medicine particularly. We'll particularly emphasize our approach towards data augmentation and how that led us to having a high accuracy without the utilization of dropout. Alzheimer's disease poses significant global health challenges, and our work focuses on creating an early detection model for the same. Alzheimer's disease affects over 55 million people globally, and there is no current cure for this particular disease. But early detection definitely does lead to better treatment and management. One thing to note is traditional diagnosis methods like neuropsychological testing or different forms of imaging do exist, but they're not as sensitive to early diagnosis. So we wanted to contribute to solving this particular gap by leveraging deep learning to analyze MRI images and thus better classify different stages of Alzheimer's. So how did we begin? We sourced our initial data set from Kaggle. Our original data set had 6,400 images, and our augmented data set had 33,984 images. The augmented dataset consisted of the original images, 6,400 images, undergoing different augmentation techniques like rotation, flipping, and cropping. Also, these images underwent different augmentation techniques like resizing, shift scale rotate, RGB shift, random brightness contrast, and color jitter. Now, obviously, resizing and normalization were pivotal to any deep learning model. They were here as well. But this is something that is deeply tied with the ablation study, and we'll discuss it at that point. Now I'd like to discuss our model. George Box once said, all models are wrong, but some have interesting results. Setting out with this exact thought in mind, we aim to create a model balancing complexity and effectiveness. Our model was based on a convolutional neural network deep learning architecture, which has proven efficient and effective for image analysis and classification over the time period. Our components are as follows: convolutional layers for feature extraction, max pooling layer for downsampling, flattened layer to convert feature maps to 1D vector, and dense layers for classification. These convolutional layers I talk about learn from hierarchical features that allow the model to detect patterns indicative of Alzheimer's disease, while these max pooling layers help us reduce spatial dimension that in turn reduce the computational cost and in turn make the model more robust for smaller variations, noise, outliers, so on and so forth. Now, there's one thing that does set us apart from all the models out there, from the models currently in use or from the models currently applied. That is the absence of an industry standard dropout layers. Now, this was a deliberate choice. Our deliberate decision to not include dropout layers is a big deviation or departure from conventional approach because it is employed as a regularization technique in almost all deep learning or convolutional neural network models. Our reasoning was simple. We felt it limited feature learning to a great extent. And for understanding why we felt that, we need to understand what dropout layers do. Basically, at random intervals during the training part of the model, they randomly drop some neurons from the model and thus ensure that the model can regularize better or generalize better and thus avoid overfitting. And we felt that the same regularization effect can be achieved without using dropout layers with a sufficiently large, diverse, and balanced training set. One of our another reasoning was that due to the stochastic natures of dropout layers, they slow down training to a large extent as the model takes longer to converge. Now, all of this was fine in theory. So how do we prove it? We prove it by looking at our performance metrics. We had exceptional performance, stellar performance, if I may, with an accuracy of 99.51%. Our precision, which is the measure of positive predictions that were actually correct, stood at 99.512%. Our recall, that measures proportion of actual positive cases correctly identified by the model, was 99.5225%, and the harmonic mean of 2, precision and recall, stood at 99.5125%. These high values implied that our model was highly accurate, reliable, and took the false positive and false negatives to a minimum. And in deep learning, as long as the performance metrics are good, all is well, right? Not really. Because now there's an elephant in the room that I would like to discuss, which is a crucial question in all things AM, in all things ML, in all things AI. That is, does the model generalize well to unseen data? Or has it simply learned or memorized the training data? Or in other words, did we overfit? To address this particular question, I would like to talk about the bias variance trade-off equation, which is the expected value of the truth value, which is y, and the model prediction, that is fx, whole square is put as the bias of the model prediction square plus variance of the model prediction fx with variance epsilon. This variance in epsilon is called the irreducible error and is the root of the George Box's quote that I gave a couple slides back. Now, we would like to focus on the reducible part of the equation, that is bias and variance. Bias here is the error caused by the approximation of a real-world problem by simple model. Or in layman's term, high bias means underfitting, and that the model has left out on some crucial relationships and different criteria. But high variance here. Variance is the model's sensitivity to fluctuations in the training data. Or again, in layman's terms, high variance implies the model has overfitted, capturing noise and other variations. Now, underfitting was out of the question because, as we saw in the previous slide, with such a high accuracy, underfitting does not exist. So we solve the bias half of the reducible error. How do we test for the variance? Well, we tried to do that in the best way possible. We took a second data set from Kaggle and ran it through our model. And I'm happy to announce that we got a 99.39% accuracy on that as well, thus proving that our model did not overfit at any point and does generalize well. Now, apart from this, there's also one important part that this particular experiment solves. That is, there was a consensus in the industry that training on augmentations particularly might lead to leaking of feature points throughout different images and thus make the model overfit more. But this particular experiment disproves that theory for our particular model. Now, why does it work? Our success is attributed to two key factors: the power of feature extraction of convolutional layers, where they learn automatically the hierarchical features from import images, including simple features like edges to even more complex disease-specific features, to even having an effective generalization, which is the ability to perform well on unseen data, which is paramount for all deep learning models and something we definitely prioritize. The simplicity of our model combined with effective data augmentation allowed us to learn meaningful representation of the data and generalize well to new data. Now, all this is fine, but this is something that led us to an important conclusion as well. A conclusion that is more theoretical rather than practical, but something that's need to be followed. That is how not to build AI. AI is a tool, not a magic wand, not a one-size-fits-all solution. Just like we don't use a pistol to deal with a mosquito, we need to select models that are appropriate to a problem, that are not complex enough, that are appropriate and fit for the model. My two favorite statisticians, Robert and Trevor Suss, say, parsimony versus black box is an important decision in any model development procedure. And it's important that parsimony is given preference even at a little trade-off. That means that in model design, parsimony or understanding how the model is working is preferable, because complexity does not always equal to effectiveness. And simpler models are more interpretable, they're more easy to understand, and they're more practical to apply. Interpretability is also extremely important in critical applications like healthcare, where transparency and trust is paramount. Now, ablation study involves systematic removal, modification, part of the model to see how performance changes over time and thus converge to a better model design overall. We had various parts of our ablation study where we talked about activation functions, where we experimented with different variants of ReLU functions, as choice of activation function is also tied to normalization that we talked about in the second slide. It is pretty important to figure out the best activation function as well. We also experimented with different loss functions that optimize model training process overall. We also optimized the kernel and filter size of the convolutional and con2D and max pooling layers of our model as well. And ablation study helped us to reach the current design characteristics and validate our choices as well. But now, how do we proceed for this? Because this is a research currently undergoing as well. We'd like to validate on other data sets as well. We'd like to conduct further ablation studies. We'd like to compare with pre-trained models that including exception models or VGGNet or ResNet, so on and so forth. We would like to conduct a deeper theoretical review of the entire thing, and a clinical trial will be the cherry on top. With this, I come to the end of my presentation. I would like to extend my profound gratitude to my university, our faculties, our staff, and my team for supporting me in this. And finally, the team of ICTIS for giving me this opportunity to present here. Thank you.
Yeah, good presentation as a BTech CSE student from VIT. So my question is, can you provide a brief explanation of what data set you have selected and why?
All right, sir. So, sir, across different models that have been developed for academic purposes, a Kaggle data set with 6,400 images has been a corner point, which many of them sticking to that particular data set. While it is a good data set, the one problem that it has is it's unbalanced to the epitome, where with non-demented being the heavier class or the majority class, and mildly demented and moderately demented being the undersampled. So at that point, we knew that this is one thing that we cannot proceed with, because we'll need to use things like SMOT or other applications to ensure that we can properly train our data set. So at that point, we went on the lookout for an augmented data set that we were able to find again with all the techniques that I mentioned previously, like augmentation and augmented techniques that made the data set more balanced overall and gave us a larger set of images to train our model.
Okay, which major features you have selected?
So, all right. So this is one place where I believe the convolution layer did all the job, and that was not something that was hard chosen by us. We had MRI images from Kaggle that we trained the model upon. Now, we let the model decide what features it wanted to pick up, and gradually it gave us the accuracy we wanted. So at that point, a human intervention of particularly finding out the features seemed redundant at the time. We do want to get into it at a later stage of the research, but at the moment we were happy with the results we got. So we did not manually pick out any features and so.
The reason for this is, for example, is this medicine related, right? So the doctors and clinical teams input also matters a lot compared to just going for that AI/ML particular methods. That's the reason. Okay,
yes, sir.
Thanks.
Thank you, sir.
Thank you. Congratulations for your work, which is very important for the society. Did you use learning curves to check how your proposal performance evolves in terms of data augmentation provided for training?
So we did not employ a learning curve in particularly, but we did map different features like the ROC curve. We did plot the classification, the confusion matrix. We did also plot how the model evolved with time with respect to epochs and all. We did do that, sir.
Okay, thank you. Thank you very much.
Thank you, sir. Have a great day. Thank you, sir, for the questions.
Thank you, sir. Sir Prasann, if you're ready, then you can go ahead.
Yeah, madam.
Yeah.
I'll start my presentation.
Sure, sir.
Am I audible?
Yes, sir, you're audible.
Yes.
Yeah. So myself, Dr. Prasanna Paga, and our team members are Suganya E, Professor Narahari Datta, Shika Maharana, Dr. Shashidhara KS, and Dr. Krishnananda Sheth, and Aditya B. So basically, we are trying to give a presentation on design and realization of a stub-loaded tri-band Chebyshev filter for Navig satellite application. So these are the contents. We start with the abstract, then introduction, literature survey, problem statement, objectives, simulation results, results and discussion, conclusion, future scope, and references. Abstract. So basically, NAVIC is an acronym for Navigation for Indian Constellation. So it's basically a consortium of 7 satellites which are revolving around the Earth for giving accurate timing and positioning information. So basically, these NAVIC signals are operating in the L band and the S band. So we have designed a tri-band filter which is operating in the L and the S band for actually getting the precise timing and positioning information. So the proposed filter operates in 3 frequency bands, namely 1.3 gigahertz, 1.5 gigahertz, and 2.6 gigahertz. And this filter has been designed on a tectonic substrate of permittivity 2.2 and thickness 1.6 mm. The structure reported a very good input reflection coefficient of below minus 15 dB in L and S band, along with a very good insertion loss of 0.1 dB, 0.3 dB, and 0.2 dB across all the three frequency bands respectively. So, introduction. So basically, as I have told, NAVIC stands for Navigation for Indian Constellation. It is basically a constellation of 7 satellites which are revolving around the Earth to give the precise information about the location and the timing. So basically, we have all mobile phones in our hand. So these mobile phones are actually using GPS systems to track the object or to track our location. So these satellites are revolving around the Earth 24/7. These signals are expected to be intercepted by the receiver, which is actually placed in the ground station to provide accurate timing and position information. So this is the literature survey. So basically, few papers have been reported on this filter design. One by name Z et al. Proposed a quad ring resonator which contains 4 resonators located at the center. This type cluster exhibits the advantage of reduced size reduction and high isolation. So next is we have other paper by name Lee et al. So he proposed an innovative single layer differential tri-band filter antenna. Strong coupling between the two driven elements were there, which resulted in with the different excitations, which resulted in performance degradation. So this operates in 3 frequency bands, 2.4 gigahertz, then 3 gigahertz, and 5.57 gigahertz with linear polarization. Next problem statement. So basically, NAVIC filters which are there are going to require high input reflection coefficient S11 and a sharp cutoff S21 response at the L and the S band operating frequency, because these NAVIC signals which are coming from the satellites are located somewhere around 1,000 to 35,000 kilometers above the Earth. So these signals may be actually subjected to interference and lot of disturbances during their journey from the satellite to the ground station because of the local service providers, which are Wi-Fi service providers or other internet service providers. They have put their own towers. So basically here the aim is to make sure that these signals which are coming from the satellite, they have to be actually filtered with over a very narrow bandwidth, as well as make sure that they are actually protected from these unwanted disturbances which are interfering the reception of these signals which are coming from satellites. So the insertion losses required are to be very low, as well as they are required to have very steep characteristics. That is the S21 characteristics, that is the pass band and the stop band characteristics have to be very narrow with very high selectivity at L band and S band frequencies respectively. So objectives. Basically, our objective was to implement a tri-band NAVIC filter resonating at L and S bands pertaining to 1.3 gigahertz, 1.5 gigahertz, and 2.4 gigahertz. To investigate the input reflection coefficient S11 and the coupling characteristics S21 of the filter to validate the insertion loss in the operating band of the filter. So this is the design of the tri-band Chebyshev filter which has been proposed here. So first one is the original filter, which you see there is basically it has got 2 ports. One is port 1 and port 2 here. So this is basically made up of 2 symmetrical C-shaped stubs with a small gap. These stubs are going to give inductance and the capacitance effect. So next we went to the next design, which is the tri-band Chebyshev filter with L stub, and finally the third design is again the same design with L and X stubs. So what we did is, using these 3 stubs, we were able to achieve 3 frequency bands of interest with very good return loss of below minus 15 dB. So this is the methodology. So first we select the desired resonant frequency bandwidth and bandwidth of the tri-band filter. Then select the order of the Chebyshev filter. Then estimate the number of subsections with impedance values to be appearing in series and parallel. Configure one of the ports as input port and the other port as output port. Then we create the 3D model of the filter in HFSS and assign boundaries and excitations. Then create a symmetrical C-shaped stub on either side to get the first resonance. Then we integrate the L shape and the X-shaped stubs to get the other 2 bands, namely 2.4 and 1.5 gigahertz respectively. So check if the S11 is below minus 10 dB at all the 3 bands, and as well as S21, the insertion loss is also in the range of 0 to 1 dB. So these are the final design geometrical specifications. One is the length of the C section stubs are 69 mm. L section stub length is 13.5 cross 7.1 mm. X section stub is 4.1 cross 4.1 mm. The substrate type is tectonic. Permittivity is 2.2, thickness is 1.6, and substrate dimensions are 41 mm cross 44 mm, and number of ports are 2 ports. One is input port, other is output port. So this is the simulated input reflection coefficient plot of the filter. As you can see here, this filter is resonating at 3 bands, 1.3, 1.5, and 2.5 gigahertz, with a very good return loss, which is below minus 20 dB, as well as with a very high S21 value. So S21 value represents the insertion loss. So as you can see, it is exactly the replica of the input reflection coefficient. If you take a mirror image of, hello? Yeah, if you take the replica of this, you can see this red curve represents the insertion loss curve, and
Excuse me, sir.
hello,
Yeah, sir. You're audible now.
am I audible?
Yeah.
Okay. So this is the input reflection coefficient of the filter with X and without L-shaped stubs. So as you can see, the input reflection coefficient is resonating properly at the 1.3 gigahertz and the 1.5 gigahertz, but the bandwidth is very narrow. So, and the third band is not at all appearing, as you can see here. This is with X and without L-shaped stubs. Then this is with X stub and without L-shaped stubs, as you can see here. Again, the bandwidth has been slightly improved, but again the S band frequencies still need to appear here. So finally, what happens is in the final design, whatever I have shown here. So in this design, all the 3 stubs are there: L band, S band, and L-shaped, X-shaped, and C-shaped stubs, because of which we are able to get the 3 frequency bands meeting the bandwidth requirement. So these are the values reported for our tri-band filter. So first one is S21 value reported is 0.1 dB for 1.3 gigahertz, 0.3 dB for 1.575 gigahertz, and 2.634 dB for 2.5 gigahertz. S11 value reported were minus 30 dB, minus 25 dB, and minus 20 dB. Then we have bandwidth reported as 800 megahertz, 400 megahertz, and 200 megahertz. Conclusion: in this paper, a tri-band filter has been designed for NAVIC communication, satellite applications, and GNSS. The filter is utilizing a tectonic substrate along with L-shaped and X-shaped stubs respectively, effectively to resonate at 3 frequencies: 1.3 gigahertz, 1.5 gigahertz, and 2.6 gigahertz. Simulation results demonstrated that the filter provides precise resonance at S and L band respectively, achieving desired performance metrics with very low insertion loss and significant attenuation at out-of-band frequencies. The potential design shows strong potential for reliable and efficient use of communication systems, particularly in satellite-based positioning and NAVIC signals. Next is future scope. One potential direction is the optimization of the filter's bandwidth to achieve better frequency selectivity, particularly for getting more compact and higher performance. Then exploring the miniaturization of the design while maintaining the effectiveness would lead to more integrated solutions. The use of advanced materials with higher permeability or metamaterials could further improve the filter efficiency and reduce the size. These are the references. Thank you.
Thank you. No questions from my end.
Thank you. No question for me also.
Thank you, sir.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Arun Karthik S with the paper title Dining Enhancing Dining Experiences with Modular App Architecture. Sir, if you're ready, then
Yes.
you may go ahead.
Yes, ma'am. Am I audible?
Yes, sir, you're audible.
Yeah, I'll share my screen. One second.
Sure, sir.
So my screen is audible, right? Visible, right? Yeah.
Yeah, sir, it
Yes.
is.
Getting to a slideshow. Yes. So this is Dineys, which is a modular application that is designed for improving dining experiences in restaurants. So before that, I'll give an introduction. So we are a group of 3 students, Arun, which is me, and Vijay from PES University, Bangalore. We are BTech CSE final year students. So this was done under the guidance of our guide, who was Dr. Gokul. So this is the introduction to our project, which is so here is a problem statement. So we are enhancing dining experiences using modern technologies and reducing common frustrations. So for that, we have given a solution, which is an Android-based restaurant management app for customers and admins. So the key features are table reservation, pre-ordering, order management, advance payment, menu exploration, and real-time synchronization via Firebase. So I'd like to explain this in simple words. So there are various existing apps like maybe Swiggy or Zomato, which let you book a table in restaurant or reserve a table in restaurant. But what we do is we give three features, unique features. That's the difference. So which is table reservation. We let a group of people reserve a table at a particular time, and we also give them the option of pre-ordering food. So which is if they want like tomorrow 7 p.m. something, so they can order now itself, and they can provide payment in advance also. So they just get a token or something like that, which they can go there and verify and immediately get their meals served. So this reduces common frustrations like waiting times and like maybe synchronization issues or something. So let me show the literature survey. So the existing solutions are as such. So these are traditional restaurant management systems like mobile-based ordering apps like Swiggy, Zomato, Uber Eats. So we have done an exclusive survey on these apps. So what they do is they allow you to reserve a table, but they don't allow pre-ordering of food. So that's one gap which we have identified. There's a lack of simultaneous integrated reservation, payment, and ordering. All these three things. So we also provide real-time updates, so which we have identified. So that's what we how Diners improves is that we provide a unified system for table reservations, pre-ordering, and advance payments and real-time updates. Here's our system overview. So this is our architecture. So we followed a modular design. So basically, we split the application as a client application where users can book, reserve table, and admin application which is for the restaurants where they can receive the orders and update their menus and synchronize everything. So which is the backend. This is based on MVVM architecture, so which is model view model. So where it connects data UI and connects them with them. So that architecture. So these are the technologies used. We have developed this as an exclusive Android application. So we used Kotlin in Android Studio. We used XML files for the front end development, and we used Jetpack libraries for the user interfaces. So backend was also written in Kotlin, and we used Firebase online database. So this also we used because this is a completely cloud-based database from Google, so which is better than traditional SQL databases. Also, it provides better authentication. So here are the features. So basically, we have two apps: the customer app where you can reserve tables, browse menus, pre-order. You can pay in advance, and you can track your orders. You get notifications for order status and promotional offers. And next is admin app. The admins can update their menus, which they provide. They can update the details of the restaurants, and they can also see an analytics dashboard where they can see who's ordering what all, and as such, which provides user control. And they get Firebase powered real-time updates. So here's a simple design which we have shown of the application. Since it's a product-based application, we had to show this. So this is the user client tab where you get interface like this. Since these details are already filled, like RF JSWAL email, based on the user ID, whatever we have. So as you can see, you can select a time slot when you want to dine out. You can even select all the food like that. You will get a grand total here. So we have integrated Razor Pay for payments. As of now, these are all under test circumstances since we have not released the app for public use. So once you get that, you can see that in your order history, the third tab. So where I've ordered one quantity of 199 rupees, this is the meals. The same will be reflected in the admin app. So their design is as such. They can see the list of all the registered users. They can modify the restaurant details as in the second tab. They can give the name, ratings, location, the photos, everything. So they can also see the restaurant orders in the last tab. As you can see, the previous order which I ordered under the name RF Jaiswal, that 499, that thing has reflected here. So upon which they can act and they can synchronize. So here we have added a simple ER diagram for this, reflecting all the entities in our thing. So this is the user, this is the restaurant. We have menu, order, restaurant menu item, and order menu item. So these are basically one-to-many relations, as in a user can place multiple orders, a restaurant can receive multiple orders, a single restaurant can have different menus and such and so. So it's basically to represent all the entities that are involved in this process. Coming to the testing strategy, we have used simple, straightforward methods of unit testing and integration testing. We used JUnit for both of them. So unit testing is, of course, a module-specific validation. Each module was tested independently. And integration testing, as we progressed, we went on integrating various components and checked both the front end and back end are working and they're synchronizing or as such. And we also did performance and security testing. We shared the APK of this application to several people and ensured that whether the functionalities are actually working and as such. So when we come to the results and challenges, so achievements is that, of course, we have successfully deployed an intuitive app with real-time updates. So we can improve customized experience and operational efficiency through functional testing and simulated use cases. Since we have not released the app publicly to restaurants yet, so we have only done use cases and testing as such among people. So the challenges which we overcome were our team had to learn Kotlin and Firebase, everything regarding these from the start. We had to go through various documentations. And there were certain synchronization issues between client side and server side initially, which were resolved. So we did this project throughout the entirety of the last year, final year of engineering. So there were a lot of takeaways for us, which was the importance of modular design for scalability. And so we also learned that proactive testing reduces long-term debugging issues. So once in a while, we have to meet our guide and regularly update the app. And we learned the importance of teamwork, of course, in the field of development and troubleshooting. So while we have done a lot, there is obviously a lot of future scope, which we have received from various people, guidance from various people, which is, of course, AI integration. Nothing goes on without AI these days. So which helps in predictive analysis for restaurant recommendations. There's also a scope for cross-platform expansion, since this is done exclusively for Android in Kotlin. So we could also do it for iOS and web versions, maybe through other like Flutter or .NET, other technologies. Performance optimization. We could also do better memory management for lower end devices as such, since I think the least device with support is Android 6 or something, which itself is quite a lot, but we could still improve. Security enhancements. We can do multi-factor authentication for our app, which we don't have currently. So these were all the references. Since this was a development app, we had to go through all the documentations for Android Studio documentation, Firebase documentation, system design tutorial from Geeks for Geeks, MVVM architecture in Android, UML tutorial for the UML diagrams and getting to know all the entities. And we had to also learn Kotlin documentation. So after this, I would like to conclude our presentation with mentioning a few things. So the key impact was a practical and scalable solution for restaurant management. Once we release this application to the outer world, we hope this will create an impact. And final thoughts is this project, of course, lays a strong foundation for future expansion. So we could go on, continue to improvise it in the future. And I would like to finally provide my acknowledgement, sincere thanks to the ICTIS conference organizers, guide, and our team. So this is it from us. Any questions?
Yeah. So as it was part of that final year, so it is good. But you can, I think, improve the UI portion and you can work upon the policies and the revenue model as you have generated or created this application, right? So
Yes.
if possible, be ready for the revenue model also. So you can earn by doing this thing also parallel to this development.
Correct, sir,
There is a
correct.
still scope of good UI, right, in your system, as I've seen the screenshot. Thank you.
We will, yes, certainly look to improvise this one. Yes. So is that all, sir?
Yeah, that's it from my side.
Yes.
Thank you and congratulations.
Thank you, sir. Thank you, both of you. Yes.
Does your system take into account the security of customers and restaurant private data?
Security. Yes. Sir. So since this
The security
the
of
data is stored
customers
in,
and restaurant private data.
yes. So that is why we are using Firebase, sir, which is a Google Cloud Storage database. So they provide automatic encryption for everything. So I believe that should provide enough security.
Okay, thank you.
Thank you. Yes.
Thank you, sir. We'll
Thank
be
you.
proceeding with our next paper presenter. I'd like to invite paper presenter Mehboob Mujawar with the paper title Real-Time Network Intrusion Detection System with Machine Learning. Sir, if you're ready, then you may go ahead.
Am I audible, ma'am?
Yes, sir, you're audible.
My screen is visible, ma'am.
Yes, sir, your screen is visible, but not your PPT yet.
Now, ma'am.
Yeah, it's visible.
Yeah. Good afternoon, everyone. The title of my research is Real-Time Network Intrusion Detection System with Machine Learning. And what we are actually doing in this research is that the main important thing is to find the network intrusions
So sorry
using
to
the
disturb
AI-driven
you,
techniques.
but could you put your
Yeah, ma'am.
presentation in slideshow mode?
It is in slideshow.
Sir, you can
Now, ma'am.
press from, yeah.
Now it is slideshow.
I
Not
think
yet,
you
sir.
need to share the full screen in that Zoom.
Oh.
Yeah,
Now.
sir, it's perfect now.
Yeah. So basically, we have made use of UNSW-NP15 dataset here using random forest algorithm, and our main aim is to find the intrusions in the networks that are happening here. So with this dataset and random forest algorithm, we had achieved an accuracy of 83.68% and F1 score of 83.14%. It is basically helping us to detect the anomalies in the real-time network, and also it is going to identify the main threats like DDoS attacks, and it is going to minimize the false positives which are basically happening in the detection of anomalies in the network. So the main aim over here is the rapid technological advancement that is actually increasing the network complexity. So as the network is becoming more and more complex, there is more and more threats that will be happening into the network. So we want to protect our network from all the threats. So the main one detection system which
I think your
is
voice is breaking.
employed over using of data set all time, and one the best result we could obtain for NSW, and also we had tried for the different algorithms, but the random for algorithm gave us the perfect results. So this is the literature survey, wherein we have referred to around 7-8 peoples, and the main key factors what we have considered over here is accuracy, precision, recall, and F1 score of all these papers. So the proposed model has offered an accuracy of 83.68%, precision of 83.02%, recall of 83.68%, and F1 score of 83.14%, which is comparatively better to the papers which are already existing. In this paper, we have developed this network traffic analyzer interface, which is the front end interface, which is actually providing us with the how many packets have been captured and whether that the traffic that has been captured is normal or it is abnormal. What kind of attacks are detected that can easily be seen here. So here we can have the network traffic analyzer index, which is having network statistics of actually how detected, and the green whatever the packets have been captured are the output for the accuracy that has been obtained by making use of the random forest algorithm. We are for comparison we have taken a support vector machine algorithm as well to compare with the random forest algorithm. So here with the random forest is offering an accuracy of 83.68%, wherein the SVM model is offering an accuracy of 63.707%. So comparatively, we can say that obviously the random forest model is performing very much better in demonstrating the robust performance on the data set, and also the network packets can easily be captured and identified properly, whether they are the normal ones or the abnormal ones. Then here we have the precision, the output for the precision, which we can see here. Same thing has been done for the comparison of random forest VM algorithms. So in case of random forest algorithm, we have achieved a precision of 83.66%, wherein for SVM model it is 47.50%, which is comparatively very much less. So this random forest is obviously outperforming the SVM in terms of precision, and also the random forest is more suitable for minimizing the false alarms in the intrusion detection. The next is about recall. So we have considered the recall measure, that is basically gives us the model sensitivity in detecting the actual traffic, that is by making use of the same random forest and SVM algorithm. So for random forest, it is offering a recall of 83.68%. That is basically this strong recall basically indicates the effectiveness in reducing the false negatives, which is our main aim here. We want all the true positives to be detected, then which ensures most attacks are obviously identified here. And in SVM model, we are having an accuracy of 63.07%. So obviously the random forest over here is again outperforming the SVM in terms of recall, and also it is effective in detecting the threats. The next one is the F1 score. That is, F1 score is basically the mean of precision and recall. And here, by making use of random forest algorithm, we are getting an F1 score of 83.14%. That is basically indicating its consistent and balanced performance. And for M model, it is around 0.89%. So obviously, again, the random forest algorithm is performing better than the SVM algorithm here. So the basic conclusion is that we have obtained higher accuracy, strong precision, and effective recall, and impressive F1 score compared to the papers which are referred in the literature review. And also the identification of the normal network activities can be easily done here, and malicious network behavior could also be kept a track of. These are the references.
Yeah.
Yes.
So have you tried this into your university network or something?
No, sir. This is the
Or
first
test bed
phase
kind of thing?
wherein we are using the data sets.
Okay. Because you
Yeah.
mentioned that real time, so that's the
Yes,
reason.
yes, sir. We had done it for a
So,
smaller packets, like just 18 packets were captured here. So for a bigger network, we'll be going in the next phase. Next phase, we are planning with the deep learning models also. Then we'll go ahead with a bigger set.
okay, fine.
Thank you.
Yeah. Thank you, sir.
Okay. Did you perform a pre-processing of your dataset? A pre-processing of your dataset?
Yes, sir.
Did you perform a pre-processing of your dataset?
Pre-processing.
Yes.
Actually, we had taken the dataset directly from the Kaggle, and we implemented it.
I just
Pre-processing
implement the
was.
dataset like this.
Yeah.
Okay, thank you.
Thank you, sir.
Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Vijay Bharti with the paper titled Speech Emotion Recognition on Rave Test Dataset Using Lightweight Discrete Hope Field in Neural Network. Ma'am, if you're ready, then you may go ahead.
Yes, ma'am. Am I audible?
Yes, ma'am, you're audible.
Yeah. Is my screen visible?
Yes, ma'am, it is visible.
Yeah, good afternoon, everyone. This is Vijay Bharati with my co-author Dr. Prashant Nitnavari to present on the paper titled Speech Emotion Recognition on Rapidus Dataset using Lightweight Discrete Hopfield Neural Network. Yes, these are the contents on which the discussion will be done. Just hold on, I just wanted to hide this. To just give a short introduction about effective computing. Effective computing is one among the emerging areas of research which enables any intelligent system to understand, detect, deduce, and respond to different emotions. Emotion intelligence has the ability to strengthen the bond with human beings in any conversation. As speech is the primary means of human communication, where each and every spoken utterance creates an emotional component which reflects the current state of the speakers. So it's very crucial for any conversational agent to be equipped with the ability to simulate human-like conversation, to understand the affective state of any speaker and respond accordingly at the particular circumstances. So many applications are there. So real-time public health systems greatly benefit from SCR to provide insights about patients' mental and emotional well-being. Different machines with SCR capabilities, they allow the medical professionals to identify different diseases such as depression, Parkinson's disease, while simultaneously they can enhance the treatment and the patient outcomes. Even unpleasant emotional states such as tension, rage, and exhaustion identification can decrease traffic accidents while enhancing road safety. Intelligent cars can detect the condition of their operators. As smart assistants, health devices, and wearables, they grow, understanding not just what is said, but how it is said becomes very critical. Devices for mental health care monitoring, such as for elder care, emotion tracking in rural clinics, they must run offline on low-cost hardware. So this is the main motivation of our research as such. The requirement for an any improvised SCR system for systems which work under resource-constrained environments, that is the need of the hour. So in order to satisfy this particular requirement, our system is specifically designed to overcome energy and latency constraints, making it a strong candidate for real-time emotion detection on edge devices, where traditional deep models often they fail due to high computational overhead. So going to motivation, what is the main motivation of this particular project? Despite significant advancements in deep learning for speech emotion recognition, many of the existing models, they suffer from high computational complexity, lack of interpretability, and poor suitability for the deployment in edge devices or resource-constrained environments, such as mobile and wearable devices, and the remote, rural, or low infrastructure settings, and on the devices which are actually operated on low battery or power. So the identified problem statement. Traditional deep learning models such as convolution neural networks, LSTMs, and transformers, they undoubtedly they offer high performance, but they are typically compute intensive and black box in nature. So achieving high classification accuracy while maintaining the low computational complexity and interpretability remains a major challenge, particularly in the resource-constrained environments like mobile, wearable devices, or other embedded systems. Hence, to address these challenges, we have designed a hybrid lightweight emotion recognition model that leverages the lightweight, associative, and energy efficient capabilities of DHNN, which is discrete Hopfield neural network, combined with a recent bio-inspired meta-heuristic algorithm called the Green Anaconda optimization to improve the classification accuracy, feature efficiency, and deployability in constrained environments. So this is the proposed system, the overall view of the proposed system, where we have worked on the Rapidus speech dataset. It includes the following steps. The first step being the pre-processing, where we have used the lightweight Wiener filter to denoise the speech signals. And the next step is feature extraction, where we have used local and global multi-scale feature fusion branch for best feature extractions. And then comes the hybrid model where we have used discrete Hopf fill combined with green anaconda optimization. So coming to the pre-processing where we have used the Vena filter, the reason for using the Vena filter especially is versatile, optimal, and completely computational efficient method to suppress the noise. So this is one of the type of linear filter used to estimate a desired signal from noisy or any degraded signal, especially the dataset Ravdes. So it was useful for us to use the Vena filter to reduce the noise, as well as it works by minimizing the mean square error between the estimated signal and the desired signal. Basically, it improves the strength of the signal. So this filter actually passes the frequency components where signal is stronger and suppresses the components wherever the noise dominates. And moving forward to the next step is feature extraction, where we have actually used the LGMS FFB, which is nothing but local and global multi-scale feature fusion branch method, which tries to capture the local features as well as the global features. Local features includes the short-term patterns such as energy burst, where as far as emotion recognition is concerned, there will be a sudden change in the emotion. So identifying the energy burst, like pitch, phonemes within a milliseconds to microseconds. And global features includes capturing the long-term emotional trends like prosody, rhythm, or speaking style. So this LGMS FFB fuses both the types of features to understand the complete emotion. So this is multi-scale. This filter can be called as a multi-scale filter, which can be used to learn from various time frequency as well as temporal scales. So depth-wise separable convolutions are actually defined in this to make it suitable for resource-constrained environments. And moving forward, the third step or the third process of this proposed methodology is using discrete Hopf-fill neural network with green anaconda optimization for classification. So DHNN, it offers a lightweight, energy efficient, and interpretable associative memory structure. It's basically a recurrent neural network, recurrent artificial neural network, but the performance is actually limited by sensitivity to weight initialization and binary input encoding. So in order to address this challenge, which is there in the discrete Hopf-fill neural network, we thought of using the nature-inspired algorithm for optimization, that is green anaconda optimization, to optimize the DHNN weight matrix, that is to converge and get the local minima. So this hybrid DHNN GAO, green anaconda optimization hybrid approach, it is an attempt as a part of investigation motivated by the need for lightweight models which can be deployed on edge devices while maintaining robust performance with low computing complexity on noisy and real-world speech data. So here in DHNN discrete Hopf-fill neural network, it stores the emotion labeled features vectors as stable states. It works on binary states as such. The default energy function, or we can call it as a loss function, that is Lyapunov energy function, it ensures that the network converges to the closest stored emotional state whenever a given is a noisy or incomplete input. So using this Lyapunov energy function, the loss function, it guarantees convergence, and predictable dynamics is one of the advantage. It optimizes the weights for better memory call, which is very well suited with DHNN, discrete Hopf-fill neural network. In order to optimize this loss function, that is Lyapunov energy function, we have used green anaconda optimization algorithm to optimize this loss function. So what is this green anaconda optimization? It is actually based on the hunting and survival behavior of the green anacondas. So with the help of which we will be able to find the optimal or the near optimal weight matrices and thresholds.
Excuse me, ma'am.
Which is, yeah.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah, sure.
Yeah.
Okay. So it searches intelligently to minimize the loss function. So most of the traditional trading-based methods, they don't work well with this discrete kind of networks like DHNN. So that's why we have actually gone for this green anaconda optimization. So to conclude, it is in with the help of the combination of these components, like using the Vena filter, LGMS, FFB, DHNN, and GAO, this hybrid model is a highly accurate and robust emotion classification pipeline, which is proposed. So this is just contents of the Revdes data set, what all available. And coming to the results and discussions, we have compared Our proposed approach with the existing approaches such as SCR MFCC, sub-band short-time Fourier transform, discrete Hopfield with adaptive variable fusion, and DCNN CQTS, where unexpectedly we have got highest accuracy with our proposed model, because being a discrete model compared to the transformer models, the latest advancement for SCR, everyone using transformer models, we got better results. So this shows the result with precision recall and F1 score of the for the 7 emotions on the Raptors dataset, and the confusion matrix, as well as the error rate graph which is shown. It shows the comparative error rate analysis of the other approaches compared with the proposed approach. So to conclude, by lowering the noise and distortions, that is using the lightweight Wiener filter, LGMS FFB, and using this DHNN net with GAO, I can conclude that this particular proposed system can be put in use for a real time on any embedded edge devices due to its lightweight design. So the main factors which we concentrated are energy efficient and lightweight. Yes, thank you.
Thank you. No questions from my end.
Thank you. I have one question.
Yes, sir.
Did your proposal take into account the challenge with homonyms or similar sound words?
Sorry, sir, these challenges?
These challenges with homonyms or similar sounding words.
Huh. So as far as this Raptors dataset is concerned, we have got the best accuracy. We have planned to deploy the model on any edge devices.
Okay, thank you.
Yes, thank you, sir.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Pintang Anisa with the paper title Towards Device Authentication Design with FHIR Integration for Healthcare IoT Systems. Ma'am, if you're ready, then you may go ahead.
Yes, please. So can you see my screen already?
Yes, ma'am, it is visible.
Okay, so good afternoon, ladies and gentlemen. My presentation today is entitled Towards Device Authentication Design with FHIR Integration for Healthcare IoT Systems. And the outlines of the presentations is from this one, from background of the study until the conclusions will be presented. So the background of the study is actually based on how we see the connected medical devices nowadays is actually being rising, and we also see the vulnerability in protective sensitive patient health informations. And from Canali 2022 also provided the information that most authentication lacks integration with healthcare standards. So we use many devices like healthcare devices such as like fitness tracker or medical devices of glucose monitoring or something like that. Is actually we want to share the information. If we want to share the data, it should be in the same data formats and the same reliable authentication, especially for the device itself, how to identify whether this device can be used in any healthcare providers. So this study aims to provide a secure and reliable authentication system, proposing a conceptual scheme and design principles tailored to the unique challenges of healthcare IoT authentications. But we trying to focus the study also based on this scope, which is we trying to propose a conceptual scheme and design principles tailored to the interoperability challenges of healthcare IoT authentications, but in terms of application layer only. So this is a position paper actually before it's being implemented. And the relevance of the study of this research is maintaining the standardized data formats for carrying claims for FHIR resources, which is later on I will be presented to you what the FHIR is about. And then the research questions is how to design the device authentication with FHIR integration for healthcare IoT systems. So we know that the problems of the authenticating the device itself and how to make the interoperability challenges to be designed later on in this authentication layer. And we're trying to see the study based on our related works to see what is actually the security requirements to the healthcare IoT system itself. So there is actually a variety of the references telling about the security requirements itself. The first one is about the protocols. So the protocols to claims the FHIR resources for healthcare data, we see that this is really promising to make an integration with the diverse healthcare systems, which is many healthcare systems has many different kind of systems. So how to make it in the same language that we can understand together, so we can see this is really such a possibility to be challenged, to tackle this challenge. And the second one is by 2021 research that telling that the protection is actually need interoperability among different healthcare systems, and it's focusing on how it's really useful in the devices. And the third one is how we see there are so many cross platforms. It's not only wearable systems, it's not only web systems, it's not only what kind of IoT devices that should be make the authentication here. It's studied by Guo in 2023. So we're trying to focusing now into the FHIR itself. What is FHIR actually? We're trying to see that this is really formatting standards is really good things to be considered. So the FHIR itself is actually they can be used for data exchange. So we can exchange the healthcare data, but using RESTful APIs and JSON-based data formats, which is actually being proposed by 2021 research. And then in another research also said that FHIR it can improve care coordinations, reduce errors, and have a personalized treatments for enhancing patient outcomes. So this is how we see the related works that already actually studied FHIR before. And we see in the existing authentication, what is the gap? Is actually considered four aspects, which is security, efficiency, tamper resistance, and interoperability itself. So the authentications here, we have to see for the four aspects, relying on the security, we see there is actually studied being secured by ECC with this elliptic curve cryptography and blockchain for having authentication itself. And the proposed education, we can see how it will be making as to adaptive systems, which is not static anymore. So trying to see whether the static can be continuously real time to the users in the device itself. So the second aspect is about efficiency, how to make it. There is no key storage to be stored, and to make it efficient in the cost itself. And the FHIR reduces interoperability overhead. And the third one is tamper resistance, which is usually it's being limited. So how to fill this gap? We can use the physical variations. They cannot be cloned into this one. So all these gaps is being filled based on those four aspects, which is the four aspects would be focusing on how to integrate all the security, efficiency, and tamper resistance into the interoperable authentication with FHIR. And by using all these gaps, we're trying to we can design all of this. And so the methodology to make it really really scientific, we make it into analytical modeling, which is what is the authentication needs that based on those four aspects that we're already trying to see from the related works. And then after that, we evaluated how the FHIR implemented into these aspects to be integrated. And we understand how the authentication flows itself that can be work in the implementation later on to work on. And we see that because there are so many kind of devices in IoT systems, is there any device behavior patterns and users context or trust requirement to specific medical environments to ensure its robustness and contextual awareness? So this trust modeling is actually being promoted here in the design. And then ensuring contextual security so that after that we can have a secure healthcare IoT authentications that consider interoperability. So here is our proposed design, which is actually based on how we make it into the core one, into hardware type, because focusing on the device itself, device authentications, and integrate the device signatures into that. And then after that, we also consider the contextual trust to see how this device can have many different kind of behavior, but we still can identify it can be authenticated later on based on the trust scores that will be resulting. And the FHIR compliance, the integration itself to make it the data that has been changed, that has been exchanged to be still valid data, and it's based on the formatted data that authenticated by the device itself by using resource mapping and interoperability checking. So all these device data and authentication information are mapped to standard FHIR resources, ensuring seamless integration with healthcare information systems. And this standardizations not only facilitate consistent data exchange, but also enhances interoperability across diverse healthcare platforms. So next we can see how this can be seen from the design flows from the device and authentication server and connected to the FHIR server. But this is the position paper that we trying to see that the resources actually coming from the authentication server itself to have to send the resource status later on to see what the context is being propagated, and then if it's already sync from the FHIR, we can complete the authentications to the device to be reported in the application layer. And to see how whether the device is trusted or not, trying to see using the trust mechanism, which is this is based on the formula that has been being learned by the related works before, which is the final trust score is based on these three factors, which is the temporal, behavioral, and historical, and it could be weighted in its trust score.
I'm really sorry to disturb you, but I'd like to remind you of the time limit. Yeah.
Okay. So the conclusion is we're trying to see that this work contributes to a secure, reliable, interoperable healthcare IoT systems and aligns with the FHIR standards. And the further study will focus on validating the security and performance, optimizing efficiency, and ensuring compliance with evolving healthcare security needs. And this is our references. And thank you for your attention for the presentation. I also acknowledge my University Malaya, for having a chance to present for this event. Thank you.
Yeah. Have you implemented this particular prototype, or you just provided the theoretical background?
Yeah, so this is a position paper actually before it's being implemented. So the design evaluation itself is actually to see the attacks later on in the further research. But now from this design, at least we already know the core to see the things that can be enhanced from the previous research that hasn't been considered the FHIR itself.
Okay, and one more from the long time point of view. So you are working for the heterogeneous IoT devices, to be specific, right? So in that case, you'll be having multiple heterogeneous or manufacturers also. So I think there'll be trust issue in the future system, trust and scoring and behavior pattern. So any plan for how you're going to solve it in future?
Well, actually, the manufacturer itself, we don't really trying to giving a scope in the layer. So because it's in the application layer, maybe for the heterogeneous systems, we can integrate with the API. So with the API later on, whether this device can take the API mechanism, so all the devices can clone from the API itself.
Okay.
Yeah.
I don't have a question. Thank you.
Thank you,
Okay,
sir.
thank
Thank you,
you.
ma'am. We'll be proceeding with the next paper presenter, Rishabh, with the paper titled A Review of AI-Powered Symptom Analysis and Predictive Telemedicine Platforms, Transforming Healthcare Delivery with Machine Learning and Generative AI. So if you're ready, then you may start with the presentation.
Ma'am, am I audible?
Yeah, sir, you're audible.
Yeah, me and my teammate is going to present.
Sure, sir.
She's going to share the screen.
Sure.
Is my screen visible?
Yeah, it's visible.
Yeah, okay. So yeah, good afternoon, everyone. My name is Reena, currently in my final year bachelor's, majoring in artificial intelligence and machine learning from B&M Institute of Technology. And along with me, there's Rishabh A. Marlecha as well, who will be presenting today as well. So our paper is on the topic, a review of AI-powered symptom analysis and predictive telemedicine platforms, transforming healthcare delivery with ML and generative AI. So let's begin with why this topic matters. Across the globe, healthcare systems are facing a lot of crisis, and majorly when it comes to affordability and timely diagnosis, especially in rural or underserved regions. There's a shortage of medical professionals and infrastructure. So this is where telemedicine steps in. It connects patients and doctors remotely, overcoming the geographical barriers. Now, if we add machine learning models that can detect patterns in the symptoms or generative AI systems that can communicate with patients, then we will be looking at a great shift in healthcare industry itself. So this paper mainly reviews how these AI tools will enhance telemedicine, especially in areas of symptom analysis, prediction, and patient engagement. Coming to the objective of our study, we have mainly three core objectives. First, we wanted to understand how different AI techniques like classification algorithms, NLP, and generative models are applied in real-world telemedicine platforms. This includes both the academic research and industry solutions. Second, we critically analyze the advantages, like the faster diagnostics and the reduced burden on doctors, and even the improvement in patient satisfaction. So, but coming to the limitations, we should also take into consideration the hallucination in generative models and the bias we encounter in datasets. Finally, we explored how these technologies, when combined thoughtfully, can result in smarter predictive healthcare systems that can go beyond, symptom checking, so that they can proactively suggest treatments and even monitor the patient wellness over time. Coming to the literature survey, so let's look at a comparative survey of key papers that mainly focus on this Gen AI and healthcare. We reviewed around 10 significant papers that was published in between 23 and 2024. So what we noticed was a common trend such that in many papers, they mainly rely on the reviews and literature surveys, highlighting only the existing challenges and frameworks. And others like other papers like the sixth research paper by Wang Zhang, they only focus on the real-world case studies and tool evaluations, particularly in rural and mental health contexts. And some papers develop prototypes like mental health chatbots, which bring more technical depth, but they have very limited scale. So what the limitations that we found were mainly the data related concerns, whether it's the quality of the data, diversity of the data, or ethical governance. There should be more focus on that as well. And also one more limitation was regarding the ML models, especially as I said earlier, the hallucinations in generative models and the lack of transparency when it comes to these type of platforms. And also the practical deployment issues like the infrastructural gaps, especially in when it comes to rural telemedicine. So the gaps that we found after the survey that we have to encounter and we have to suggest more ideas were the limited scope of Gen AI in current systems. So most reviewed works use Gen AI for basic applications. However, only few explored interactive generative models for real-time decision making. And also, we found that there is a lack of personalized AI consultation. Like most models generalize across conditions and they neglect the individual histories or behaviors of that specific user's um, symptoms. And then the insufficient mental health support. There's minimal integration of therapeutic chatbots or the emotional support system alongside the symptom analysis. So coming to how symptom analysis can be done with AI, when it comes to telemedicine, symptom analysis is the first point of interaction. Initially, systems used static or rule-based algorithms, but these failed when symptoms were vague and combined or described in natural language. So that's where machine learning, especially supervised learning models, came in. By training on large data sets like patient histories and models like logistic regression or random forest, we can classify the possible conditions. For example, say we have symptoms like cough, fever, and fatigue, the model might predict as it has COVID-19 flu or pneumonia with associated confidence levels. Moreover, uh, NLP and LLMs like GPT can also handle the unstructured inputs. For example, if a patient type, I feel pressure on my chest and it's hard to breathe, a rule-based system would struggle. But the GPT can understand those semantics and it will properly interpret the emotion behind those words. So that's where ML really plays a big role. Coming to the predictive models that can be used in this telemedicine, prediction is like the real power of AI. It's not just about reacting to symptoms; it's about anticipating the disease as well. Platforms now ingest the real-time data from smartwatches, fitness bands, or even smartphone sensors. This enables continuous monitoring and alerts even during emergency interventions. So ML also reduces this clinical workload. So, doctors can focus on critical cases, and while simultaneously AI will handle these reminders and follow-ups as well. So this will result in a very personalized treatment plan and can be, it will be very helpful to most of the users as well as the doctors. So Rishabh will be taking over the presentation.
Yeah, coming to the Gen AI part in healthcare, I think Gen AI, generative AI in general, brings in human-like communication, which is essential for trust in digital healthcare. We can use chatbots like GPT or similar models and simulate empathetic conversations, particularly helpful in mental health. For an instance, someone dealing with anxiety might prefer talking to a bot at 2 a.m. rather than waiting to see a therapist. These bots can offer CBT like techniques, mood tracking, or just lend a non judgmental ear. This can also help in like a patient triage. A patient might say, "My stomach's been hurting since last night." The AI can ask relevant questions, check severity, and guide them whether it's self care or contacting a doctor. Another use is patient education. Many people don't understand medical jargons. Gen AI can explain them, like things like hypertension in layman terms, increasing health literacy. And then I'd like to move on to the next slide. So yeah, this is a proposed solution of our model where we'll be using three components, which is the symptom analysis module, a mind bot. We have named the mind bot as Lumi, and a book appointment uh, function. So when a person comes on our platform, he can analyze the symptoms what he's facing, and if a disease is predicted through our ML model, that disease will be matched with the relevant disease. That disease will be matched with the like related doctor, and then a virtual consultation can be held by, and we have stored all the doctor data sets in the Firebase Firestore. And then Winebot as well. When a disease is not predicted, the bot can provide like precautionary measures and more information on disease and how to go about it. As well as can give empathetic conversations and act like a psychologist and help you like overcome things a person is struggling to. And I'll talk about the case components. So the logistic regression trained will be trained on labeled data sets with symptoms to diagnosis mapping. If the model is confident, it will give a probable diagnosis. The AI consultation module, if the confidence is low, instead of guessing, the model offers a general advice like home remedies, when to seek care, and etc. And the mental health chatbot will build using sentiment analysis and response generation. This component focuses on well-being support. It can even track mood over time and give behavioral nudges. Doctor consultation, coming to doctor consultation, lastly, like no AI is complete without a human in the loop. So our platform allows the user to escalate to a real doctor when needed, ensuring trust and safety. And then the challenges that and limitations that we are going to like face in this will be data privacy is la paramount. Health data, if leaked, can be exploited. So encryption and strict access control are essential. Hallucination is at a big risk in LLMs. Hallucination is like a big risk in LLMs. For example, if the chatbot says you're probably having a brain tumor when it's actually a migraine, the consequences can be serious. And another is bias. So when you're training data in mostly like urban settings, the model may underperform. Or on females, if you're training the data on male, like in urban settings, the model may underperform on females or rural population, leading to unequal care. And regularization like HIP AA in the US or GDPR in Europe mandate how data can be stored and shared. Many startups struggle here, so regulatory compliance must be a part of the system. And the future directions will be the future is incredibly promising. We'll use fine-tune LLMs on clinical data, will reduce the hallucination and improve the relevance. And we'll integrate our platform with IoT wearable devices with enabling protective care. Imagine getting a warning from your watch before your heart rate spikes dangerously. And then hybrid models, AI plus human supervision will combine the speed of machines with the judgment of doctors, making care more safer and scalable. Conclusion in summary, the AI powered telemedicine system are not just tools, they are enablers of equitable, accessible, and efficient healthcare. Whether it's a chatbot handling the first contact or predictive model warning of future risks, these technologies empower both patients and professionals. But then they must be used responsibly, designed for inclusivity, tested for fairness, and aligned with medical ethics. The future of healthcare will be a collaboration between humans and AIs and not replacement. That's what makes this field both exciting and important. And lastly, I would like to thank all my teachers at college back here and my co-authors for guiding me through the project, through the review paper and research paper. And I would thank you for your attention. And I would love to hear your thoughts or questions.
Yeah, good overall survey. Looking for that implementation in upcoming conferences.
Thank you, sir.
Thank you and congratulations. Did you plan to collaborate with healthcare professionals? Was the future work?
So as of now, we haven't planned because we've yet to build a prototype model of this implementation. And once we gather build a prototype from the data set available online, then we might later plan to collaborate with the healthcare officials.
Okay, thank you.
Yes, sir.
Thank you, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter. We have Pankaj Verma with the paper titled A Study on Software Defect Prediction Using TabNet and Ensemble Machine Learning Models. Sir, if you're ready, then you may start with your presentation.
Yes, hi, I'm ready. I'm sharing my screen. Please let me know
Sure,
when you're
sir.
able to see it.
Yes, sir, it is visible.
All right. Yes, good afternoon, respected judges, and hi, everybody. This is Pankaj Verma, and today I'll be talking about the study which we did on the software defect prediction using TabNet and example machine learning models. And in the interest of time, I'll keep it a bit concise. So this is the contents which I'll plan to cover. So coming to the abstract and the background of the problem, in the industry and academia, I think one of the biggest challenges is when people are working on the software development projects, right? So there are a lot of comments and there are a lot of issues in the software in terms of bugs, which sometimes is addressed and most of the time it is also not, or even if one or two bugs are remaining, right, in the productionized software, then it becomes a major challenge, right? And this issue is across industries. So from this study, from this experiment, we wanted to compare different classification algorithms like XGBoost, Random Forest, and others with a new classification algorithm, which is deep learning based, which is called TabNet, which is a recent algorithm, and Google has created that algorithm to perform well on a tabular data. So we wanted to compare basically all these algorithms and see their accuracy and see how feasible it is to implement these algorithms in the live projects, the software development projects. So for this, we took an open source data set from the Kaggle platform. So this data set had about 120 features. So these features are corresponding to different software complexity, change history, defect matrix. There could be some other comments as well. So we took this data and we basically pre-processed it, and then we used the machine learning algorithms to classify it. So here is our methodology. So to start with, we took all this data and then we basically in the data pre-processing step, we did the label encoding for the categorical data to the numerical data. And then we observed that this data was also imbalanced. So we used the oversampling algorithm to basically balance out the data set between bug versus no bug categories. And then we perform the feature selection. And then we scale the features with the help of normalization techniques. And then we split the data sets into training and test data. We trained it, and then we ran the training, and then we did the prediction. So going a bit more detail into the data pre-processing. So we removed all the column where more than 25% of the values are missing. And we basically excluded all the non-numerical features. Then we, for the target column, which is bug and no bug, we converted this into binary classification. So earlier in the data set, it was like a text-based classification, like no bug and bug, and we converted it to 0 and 1. And then we did the imbalance handling, feature selection, scaling, and then splitting. So here is a bit about the TabNet. As I said, the TabNet is a very recent algorithm created by Google. So the idea was to basically train this algorithm to work well on the tabular data set. And it was very impressive. I mean, there are few research paper on this TabNet algorithm. So this is a deep learning based algorithm. So it is impressive to basically find out the accuracy I mean, to have high accuracy on the classification data set. It not only works on the classification type of problem, it also works well on regression problem. And the advantage of this is that it has built-in interpretability. That means when it predicts, So it goes row by row, and for each row of the data, it sees like what features are important. So when it does the prediction, it also can provide you why it did that prediction, and out of all these 120 features, what features were important to come up with the final prediction. So interpretability is one of the biggest advantage of this TabNet algorithm. And it handles classification and regression tasks, as I already told. And it also doesn't need a lot of heavy data processing as compared to other classical ML algorithm. So when we ran the feature selection, it gave us like top 20 features listed here. And we also balance the data, which is displayed on the right-hand side. And then we compared these algorithms, XGBoost, Gradient Boost, Random Forest, SVM, Logistic Regression, TabNet. And also we created a voting classifier just to basically take the voting of all these algorithms. And based on the majority voting, we classified each and every row, whether it is a bug or not, just to see if the voting classifier improves the classification accuracy or not. So for this one, the matrices which we have used is accuracy, FNS score, precision, and recall. And this is what the conclusion is. So even though TabNet is excellent is excellent deep learning algorithm to perform well on the tabular data set, but still the classical ML algorithm like XGBoost achieved the highest accuracy, which is 93.17%. And the AUC was also very high. And then random forest and gradient boosting, they were like quite good. They perform well, but not as good as XGBoost. The voting classifier is the third in terms of accuracy. And if I go here, so this is basically my confusion matrix. And again, it shows you that the confusion matrix of voting classifier, which is the ensemble machine learning model. So it is great, but if you see the XGBoost, right? I mean, it is able to classify most of the classes in very accurate manner. Right? It has very less false positives and false negatives. And if you see the ROC curves, again, XGBoost performs the highest, which means that it is able to differentiate between the true positive rate and the false positive rate. So yeah, this is again the model comparison. Again, based on this one, XGBoost has the highest accuracy, precision, recall, and FNS score. So I'll conclude it here. So in terms of future scope, we will fine tune the TabNet model, and we'll again see if it is able to perform better than most of these ML models. And second thing is, we are also thinking of integrating large language model in this solution. Because sometimes when the end users or the software developers put some commentary into it, large language models are able to basically handle them well and interpret it so that to give like the good real-time suggestion to improve the code or remove the bug. Right. And the explainability would also try to improve explainability a bit more by integrating the voting classifier, which has the TabNet model and large language models. And we are also planning to deploy it real time on the Azure machine learning workspace, where we create an endpoint out of this model and integrate this endpoint to a GitHub repo, where people are collaborating on writing the codes. So once somebody writes the code and basically submits it, this pipeline will trigger, and it'll on the real time basis, it'll basically it'll suggest if this code is likely to be a bug or not, or any particular lines are going to be a bug or not. And this will also give a recommendatory action because we will integrate the large language model, like what kind of actions or improvements you have to do to improve the code base. So with this, I'll conclude my presentation. Thank you all for your time, and I'm open for any questions or suggestions. Thank you.
Yeah, excellent presentation. Looking for the time when you are going to put in that Azure, and we will see that effect in the real-time CI/CD. That will be helpful for the students also, as well as interns also, and at normal local companies also. Thanks.
Thank you, sir.
Thank you and congratulations for your fruitful presentation.
Thank you, sir.
Thank you, sir. That was our last presentation for this session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I'd also like to thank our session chairs. Just a second. For chairing the session, a token to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you very much, and congratulations for this fruitful session.
Thank you, sir. I'd also like to thank our session chair, Professor Pritesh Kumar Prajapati, for chairing the session.
Thank you, Ishita, as well as Hers and Dr. Diallo, sir, for coordinating this kind of wonderful event. Thank you.
Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you.
Thank you.